So we were talking about, I think, we were talking about collisions. So I told you that there are two types of classifications of collisions. Uh, One is that you can classify based on energy, and the other is you can base the classification on direction of velocity. So here we saw that there is something called an elastic collision and an inelastic collision. And here we saw that there is something called a head-on collision and a oblique collision. Right? So a collision may be elastic head-on or elastic oblique, or it may be inelastic head-on or inelastic oblique. Okay. But I want to give you a better definition of elastic and inelastic collisions. And to define in a better way the concept of elastic and inelastic collisions, I will have to introduce two new concepts. Okay, so I will talk about two new things. First, I want to talk about the concept of impulse. Well, this is very misunderstood term, and uh, the terminology is uh, used uh, in a very weird way. In fact, I am also going to uh, जिसको मुझे impulse नहीं बोलना चाहिए मैं उसको impulse बोलने लग जाऊंगा. Because there are two things, the two concepts that I want to talk about. Their names are very similar to each other. So first, we are talking about the concept of impulse, which is a standard physical quantity in physics, just like force, just like acceleration, just like velocity. Now, if you remember, I told you that velocity and acceleration and force, they are all mathematically very precisely defined quantities. Okay, although we use these words in our daily lives as well, but the best example would be work. So, work done, we use this word in our daily lives, but work done in physics has a very, very specific meaning. In fact, it is the line integral of the force carried out from the initial position to the final position along a particular path. Right? So that's extremely specific. So in the same way, this quantity called impulse, which is a word that we use in our daily lives, which has a completely different meaning. So this word impulse has a very specific mathematical meaning in physics. And the meaning of the word impulse is change in momentum. So first of all, it is a vector quantity. It is a vector quantity. And the symbol that we will use use J. Okay. Why do they use J and ये तो ये आप this is a question I cannot answer. But in some textbooks, the symbol is different. I will use J. And mathematically, the impulse is the change in momentum. Okay? So the units of impulse is the same as momentum and is equal to kilogram meter per second. So whenever an impulse is imparted onto the system, this is how to use the word. Whenever an impulse is imparted to a system, that means that the momentum of the system will change. Now, you may say that I can use the same sentence with the word force instead of impulse. When a force is imparted on a system, its momentum will change. Right? And you are absolutely right. So, what is the difference between force and impulse? Well, force is equal to the change in momentum divided by time. But the change in momentum, which is the impulse, is the force multiplied by time. Or I can write J is equal to integral of f dt. Okay? So force and impulse are extremely closely related to each other. If you multiply force with time, you will arrive at impulse. So, what is the difference between impulse and force? Let me repeat that statement. If an impulse is imparted to a system, the momentum of the system changes. The second statement I made, if force is applied on a system, its momentum changes. So, both these statements are absolutely correct. Right? Now, I'll give a third statement. If a force is applied on a system for a particular interval of time, then its momentum changes. And the change in momentum will be equal to force applied multiplied by time, which is nothing but the impulse imparted to the system. And so, force multiplied by time gives us impulse, and uh, impulse divided by time gives us force. Okay, so impulse is a vector quantity which represents simply the change in momentum. But wait a minute, we know what integration means, right? So what is the physical interpretation of integration? Do you remember? What is the physical interpretation of integration? कोई बता सकता है मुझे? हाँ, very good, Satyam. It is area under the curve. Yes, exactly. Very good. Very good. Yes. So this means that if I were to draw a curve, okay, if I were to draw a curve between F and T, so if I were to draw a curve between F and T, then the area under the curve would be equal to the impulse of the object, impulse on the object. So area is equal to impulse.
सर
हाँ,
सर लेफ्ट हैंड साइड में भी इंटीग्रल साइन होना चाहिए ना
क्यों
इंटीग्रल चाहिए वेक्टर
क्यों होना चाहिए भाई?
सर क्योंकि डेल्टा डेल्टा जे होगा तभी तो।
नहीं नहीं, डेल्टा जे नहीं होएगा, जे होएगा।
सर बट ऊपर वाले इक्वेशन में फिर
ए,
जे।
डेल्टा जे नहीं होएगा, जे होएगा। ये जाएगा इनिशियल टाइम t इज इक्वल टू 0 टू t इज इक्वल टू, तो बोल रहा है, मुझे समझ में आ रहा है, आई अंडरस्टैंड व्हाट यू आर सेइंग, बट इट विल नॉट हैपन दैट वे, it will not be delta j. So what you are saying is that, look, you have defined j as fdt, so you integrate the left hand side and you integrate the right hand side, so you get this on the right hand side, and on the left hand side you get this. So no, this is not the way that it is going to work. So integral f dt is actually defined as the impulse, right? So I have actually worked it out the other way around, and therefore the confusion in your mind. This is the definition of impulse, and from here you arrive at this point. If you integrate and you find that the force is constant, you take out the force and you end up integrating dt. When you integrate dt, you get delta t, tf minus ti, and that is j. Okay?
ओके सर।
Okay. So this is one concept, and I'm not going to give you questions on this. The questions are very we are going to use this later on, but the questions are very straightforward. uh, ये फोर्स लगा, इतने टाइम के लिए लगा, प्लीज टेल मी द इम्पल्स, या फिर फोर्स का एक फंक्शन दे दिया, फंक्शन ऑफ टाइम दे दिया फोर्स को, और बोला इम्पल्स निकालो, तो आपको इंटीग्रेशन कैरी आउट करना पड़ेगा। एफ इज इक्वल टू 5t² प्लस 3t दे दिया, please tell me the impulse in the first 5 seconds. So 5t² plus 3t integrated with respect to dt from 0 to 5 will give you the answer. Okay? The other concept that I want to talk about, the other concept that I want to talk about, number two, is called the concept of impulsive force. Right? Now you see what is the source of confusion and what will be the source of confusion. The two names are very similar to each other, although they have got nothing to do with each other. So there is a concept called impulse, which is a generalized concept in physics, can be used everywhere, can be used anywhere. And there is another concept in physics, that of impulsive force, which has a very small, uh, which can be used only in a very small set of problems in physics. So what do we mean by impulsive force? Right? Force we already know. अब ये impulsive force कब हो जाएगी? Force impulsive कब हो जाएगी? So if I again were to draw a graph between force and time, so this is time, this is force. Right? We are only talking about the magnitude of force. Worst case scenario, we can talk about the one-dimensional direction of force. So if we have a force which does not exist, but then suddenly and for a short period of time it does exist, and its magnitude is very large. So this is the time interval for which the force exists, and this is the magnitude of the maximum force that exists. So if F is large and delta T is small, then force is called impulsive force. Now, how does confusion arise? Uh, एक comet एक comet जा रहा है. So this is the Earth. This is a comet. Comet is moving like this, right? And it, and because of the Earth, uh, the comet is going to get deflected. Okay? And this happens all the time. This happens all the time. Yes, catching a ball. Yes, absolutely. Yes, 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 yes. So a comet is moving like this. Okay, and what happens is that there are two quick ounce, punch, हाँ बिल्कुल yes. देख लो पहले मेरा एग्जांपल देख लो. So a comet will go like this, and usually what happens is that because of the Earth's gravity, the path of the comet changes. Okay. In fact, this is a very common thing that we use to uh, accelerate spacecraft. For example, the I don't know whether you have heard of Voyager spacecraft. The Voyager spacecraft was launched in the late 1970s, and it is the farthest man-made thing right now in the universe from the Earth. So the Voyager 2 has, I believe, just crossed the solar system. I think it crossed the solar system some time back. So the Voyager spacecraft are basically, for practical purposes, the first man-made objects that exist in interstellar space. They have left the solar system. So since the Voyager spacecraft, or any other, for example, any other spacecraft that you are launching to study the outer solar system, right, then it is not practical to have fuel on the spacecraft so that it can have a rocket which is powering its flight from the Earth in a straight line to Saturn, let's say. We want to study Saturn. A much better option and a much cheaper option is to use the gravity of the massive planet Jupiter, maybe one of its moons, to slingshot towards Saturn. So what they do is that instead of making the satellite which is going to study Saturn point at Saturn and travel in a straight line, they are going to send it towards Jupiter. It is much closer. It is much closer than the planet Saturn. And then what the spacecraft will do is that it will just like the diagram that I have drawn. It will be deflected by the gravity of Jupiter. And if we are very careful, if we are clever, then what will happen is that the outgoing kinetic energy will be slightly greater than the incoming kinetic energy. We are basically using the gravitational energy of Jupiter to power the spacecraft further, right? Okay, so this is a very common technique used to नहीं जो है मैंने बोला ना यू हैव टू बी क्लेवर अबाउट इट. वो जाके जुपिटर में घुस जाएगा ये नहीं चाहिए ना हमको, which is the other possibility that I was talking about, that a comet may come like this and may strike the Earth. path. Yes. Though a comet comes and strikes the Earth is a possibility, and a comet being deflected by the Earth is also a possibility, right? And we all hope and pray that uh, डिफ्लेक्शन वाला प्रोबेबिलिटी ज़्यादा रहे, कोलिजन वाला प्रोबेबिलिटी कम रहे, राइट? ऑल्दो हमारे ह्यूमन हिस्ट्री में कभी बड़े कॉमेट का कोलिजन नहीं हुआ है. आई थिंक वन कॉमेट इज going to collide with Earth 2036. It is not going to collide, of course, but the probability is significantly higher as compared to other large comets. Probability is something like 0.09%, which is very small really, but it is bigger than the probability percentages of other हाँ तो राधिका अगर impact हो गया तो then it is it depends on the size of the comet really. The comet's name I think is Apophis, which is going to collide. So if the comet is large enough, it may be an extinction level event, or if the comet is small enough, then it will be just pretty fireworks that we can see. If the comet is somewhere in between, then of course there will be some permanent damage to the environment, to the atmosphere, to us. Anyways, so if we have a comet which just gets deflected, जोहेब गूगल छोड़ दे तो गूगल छोड़ दे बहुत तेज गूगल पे नहीं जाना है. So if we have a comet which is just deflected by the Earth, right? Then you see the velocity of the comet has been changed from this to this. Therefore, the momentum of the comet has changed. Therefore, we say that impulse is imparted to the comet. Okay? Definitely, some impulse has been imparted to the comet by the Earth, and therefore its trajectory has changed. In this case, of course, the velocity was like this, and now the velocity is zero. So, in this case, also, we will say that impulse is imparted to the comet by the Earth, definitely. However, this time the force on the comet, which has been applied by the Earth, or you can say using third law the other way around, the force applied by the comet on the Earth is impulsive. Please note the uh, difference in statements. In both cases, impulse is imparted to the comet by the Earth. Okay, why? Because due to the Earth, due to the gravitational force or any other force. In the first case, it is the gravitational force. In the second case, it is the normal reaction. So, due to the force applied by the Earth on the comet, in both cases, the velocity of the comet changes, and therefore we say that impulse has been imparted by the Earth on the comet. Right? Therefore, the momentum of the comet has changed. In the second case, however, the force on the comet while the collision takes place, while the comet is colliding with the Earth, the force on the comet and of course the force on the Earth is huge, but only in that duration while the comet is colliding with the Earth, right? And it is this event which produces a caldera. A caldera is a geographical feature. It may be produced by volcanoes or it may be produced by the impact of a comet. Right? One of the most famous calderas they exist in in I think Peru or New Mexico, somewhere there, uh, which was the site of impact of the comet that hit the Earth around 62 million years ago, which wiped out the almost wiped out all living things on Earth. Something like 98% of the species were wiped out. Right? No, it is not long. No, it is not long. Atul. No, size of duration of the force acting on the comet is not long. No, 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 no. If you talk about the gravitational force acting on the comet, yes, very very long. Yes. So let's plot the force on the comet. Yeah, let's plot the force on the comet. So in the first case, the gravitational force on the comet will start from zero, it will go to a highest value, and then it will decrease down to zero. Right? When the comet is very far away, no gravitational force or no significant gravitational force. As the comet approaches the Earth, the gravitational force increases, and as the comet goes away, again the gravitational force decreases. Right? So this is the deflected comet के लिए graph. Right? And now we can draw the graph for the impacted वाला comet जिसका impact किया Earth पे. So the gravitational force due to the Earth is increasing, increasing, increasing. But I'm not interested in this. No, I'm not interested in this. I am interested in the point where contact is made. Okay? नहीं constant नहीं 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 नहीं. हाँ ये 9.8 है ये. हाँ ये 9.8 मीटर पर सेकेंड स्क्वायर है. इसका मतलब कि वेलोसिटी कॉमेट की इंक्रीज करती जा रही है ना. एग्जैक्टली 9.8 तो नहीं होएगा. F is equal to gm1 m2 by r square से निकालना पड़ेगा. But the point is that the distance between the comet and the Earth is constantly decreasing. Therefore, the force on the comet is constantly increasing. But I'm not interested in that force. No, no, no. I'm not really interested in that force. I am interested in the force the comet makes an impact on ground. So when the comet makes the impact on the ground, of course, the gravitational force is still acting between the Earth and the comet, right? But the gravitational force does not change. Okay, so very good. The gravitational force does not change; it remains the same. But suddenly, हाँ, अर्थ पे लैंड करने के बाद जब लैंड कर गया कॉमेट सब कुछ सेटल डाउन हो गया, then again the gravitational force is there. And then the gravitational force will be constant, right? It will not be changing with time. ये impact हो गया और ये आपका gravitational force constant हो गया. But during the point when the contact occurs, वही तो damage करता है ना. अगर 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 केवल ग्रेविटेशनल फोर्स लगता रहता कॉमेट पे तो हमें तो कोई डैमेज ही नहीं होता, कोई प्रॉब्लम नहीं है. इट इज द इम्पैक्ट मेड, it is the force due to the impact made on the comet which really goes, and I don't think I can even draw it here, which goes very very high, very very high. This is a very short period of time. This is a small period of time. Okay? And therefore, this is the impulsive force. This is the impulsive force. क्या यहाँ पे क्या यहाँ पे कॉमेट के ऊपर इम्पल्स लग रहा है? हाँ बिल्कुल लग रहा है, कोई प्रॉब्लम नहीं. क्या यहाँ पे लग रहा है? हाँ लग रहा है. क्या यहाँ पे लग रहा है? हाँ लग रहा है. इम्पल्स जो है वो यूनिवर्सल है. इम्पल्स हमेशा लगता रहे. अगर फोर्स लग रही है तो इम्पल्स हमेशा लगेगा, राइट? बट इम्पल्सिव फोर्स अनकॉमन है. इम्पल्सिव फोर्स के लिए ऐसा ग्राफ हमको चाहिए. ये दोनों फिनोमेना ये दोनों फिनोमेना को कोलिजन बोला जाएगा. ये भी कोलिजन है अर्थ के साथ कॉमेट का, और ये भी कोलिजन है अर्थ के साथ कॉमेट का. ओके, but we will concentrate our focus on collisions like these. We will focus our attention on collisions where the forces become impulsive. हाँ, impulsive forces का value हमेशा बड़ा होता है. हाँ, yes, yes, absolutely, always, always, yes. As compared to something else. I mean, as compared to zero, as compared to पार्टिकल एक्सीलरेटर यूज करके बॉम्ब बनाया. क्या बकवास कर रहा है? शॉर्ट पीरियड ऑफ टाइम. यस पार्ट, यस, शॉर्ट पीरियड ऑफ टाइम. मतलब जोहेब जो बोल रहा है ना, तो इट्स जस्ट लाइक मी सेइंग हम नेहरू रेलवे स्टेशन को बॉम्ब बना देते हैं. नेहरू रेलवे स्टेशन को बॉम्ब थोड़े बना सकते हैं. पार्टिकल एक्सीलरेटर को तो बॉम्ब कैसे बना दें? क्या मतलब है? मैं अपने बिल्डिंग में जो पावर जनरेटर है उसका बॉम्ब बना दूंगा. क्या मतलब है? मैं तेरे ऊपर फेंक दूंगा पावर जनरेटर. सर, लाइक बॉम्ब ड्रॉप किया, देन इम्पल्स एंड इम्पल्सिव फोर्स बोथ रहे. हाँ, बॉम्ब जब ड्रॉप किया अभी टाइम, हाँ रजत, टाइम तो है. ओहो, जब बॉम्ब ड्रॉप किया, राइट, वी आर टॉकिंग अबाउट अ बॉम्ब एंड आई एम अज्यूमिंग दैट वर्ल्ड वॉर टू वाला कॉन्सेप्ट वाला बॉम्ब, जहाँ पे एरोप्लेन से सिंपली उसको ड्रॉप कर दिया. राइट, एरोप्लेन से बॉम्ब को ड्रॉप कर दिया. तो यहाँ पे इम्पल्स और इम्पल्सिव फोर्स क्या है? So the impulse is being imparted to the bomb itself by the gravity, and therefore the momentum of the bomb is constantly changing. After some time, due to air resistance, its velocity will become constant, and at that moment, the net force on the bomb will become zero, and therefore its momentum will stop changing, and therefore no impulse will be imparted. No net impulse will be imparted to the bomb. Okay. Now, when the bomb hits the ground, okay, I'm not talking about the explosion itself. The bomb is simply hitting the ground when. एक मिनट, एक. हाँ, sorry. So when the bomb hits the ground, the explosion has not occurred as yet. When the bomb hits the ground, normal reaction between the bomb and the ground, which was zero to begin with, suddenly blows up, suddenly goes up. So we will say that an impulsive force is acting on the bomb. Now, of course, the bomb explodes, and when the bomb explodes, it will apply an impulsive force on all that is around the bomb. बॉम्ब के बाजू में चेयर रखी है, बॉम्ब के बाजू में डेस्क रखा है, I don't know, whatever. When the bomb explodes, then the bomb is going to apply an impulsive force on all the objects that are in the surrounding. क्योंकि force by the bomb on the chair was zero to begin with, right? And suddenly that force has gone to a huge value, and therefore the chair will acquire a large velocity in a very small period of time, and it will be blown away, जैसा हम अपने मन में visualize कर रहे हैं. Okay? So हाँ, बिल्कुल, हाँ, कोई भी ऑब्जेक्ट को अगर हम एक सिग्निफिकेंट ही नहीं, इनसिग्निफिकेंट हाइट से भी, मतलब अगर आप, हाँ, 1 मीटर से गिराओ, 2 मीटर से गिराओ, तो इम्पल्स उसके ऊपर इम्पार्ट कौन कर रहा है? अर्थ कर रहा है, क्योंकि उसका ग्रेविटी की वजह से उसका वेलोसिटी चेंज हुआ। बट एट द पॉइंट ऑफ इम्पैक्ट ऑन द ग्राउंड, the normal reaction becomes impulsive. Gravity can never be impulsive. It is impossible for the gravitational force to be impulsive. Okay. It is impossible because the gravitational force cannot suddenly change its magnitude, unless, of course, आप अचानक से कहीं पे ब्लैक होल ले आओ मेरे सामने और बोलो कि ये देखिए ये क्या है, मेरे ऊपर अचानक से इतनी फोर्स लगे कि मैं घुस गया ब्लैक होल के अंदर, तब ठीक है, तब हम बोल सकते हैं हाँ इम्पल्सिव फोर्स हो गई। बट since that is not going to happen, and if I get sucked into a black hole, all of you will also get sucked into a black hole. So since that is not going to happen, therefore we say that the gravitational force is a non-impulsive force. Gravity cannot ever be an impulsive force. In the same way, spring force can never be an impulsive force, because spring force cannot suddenly increase. Now, you may say कि नहीं सडनली क्यों नहीं इंक्रीज कर सकता है? बिल्कुल कर सकता है, लेकिन स्प्रिंग फोर्स सडनली इंक्रीज नहीं कर सकता है। इफ यू थिंक अबाउट इट, बिकॉज स्प्रिंग फोर्स के दोनों एंड्स कहीं से कनेक्टेड होते हैं, किसी मास से कनेक्टेड होते हैं। तो सडन चेंज इन लेंथ ऑफ स्प्रिंग would mean a sudden displacement of that mass, and that is not really possible. बलून को ड्रॉप करेंगे तो इम्पल्सिव फोर्स बहुत लेस लगेगा, हाँ बिल्कुल यस, बट वो इम्पल्सिव डेफिनेटली होएगा, बिकॉज इफ आई प्लॉट द नॉर्मल रिएक्शन बिटवीन द बलून एंड द फ्लोर, then I am going to get a diagram which will be like this. Normal reaction between the balloon and the floor will be zero. Suddenly it will go up, and then it will come down and then again be zero once the balloon has bounced off. Okay, so I'll give you a couple of examples and I'll ask you whether the force is impulsive or non-impulsive. तो ये जो impulsive force है ना, इसी को मैं बार बार impulse बोलते रहूंगा, यही गड़बड़ है. This is the thing that is going to get confusing later on. Impulsive force को मैं impulse बोलते रहूंगा, जबकि impulse अलग चीज है, impulsive force अलग चीज है. I'll try to be careful, but this is how it has been. I hope I don't do that, but if I do, then you will have to understand that I'm not really talking about the impulse. Impulse हमेशा रहता है. I'm talking about impulsive force. So this guy is moving with a velocity v, and they collide with each other. So we have normal reaction. अभी रुक जाओ ना, मुझे पूछने दो क्या impulsive? N1, N2, N3. N1, N2, N3. इसमें से कौन कौन से forces impulsive है, कौन कौन सी non impulsive? N1, N2, N3. N1 is the normal reaction between the two spheres, and they are identical. The two spheres are identical when they collide. N2 and N3 are the normal reactions by the floor on the two spheres. Very good. Yes, yes. This will be impulsive. This will be non-impulsive. This will be non-impulsive. Okay. N1, N2, N3, if you plot, then their values will always remain mg. N2 and N3, if you plot, then their values will always remain mg. Their values will not change. That is why. So we have another sphere moving with a velocity v, and it is striking this sphere of smaller radius. ये n1 है, ये n2 है, ये n3. n1, n2, n3, which are impulsive and which are non-impulsive. Which are impulsive, which are non-impulsive. मैं पहले आंसर बता दे रहा हूँ, फिर मैं एक्सप्लेनेशन देता हूँ. बहुत उड़ गया क्या मतलब है? Impulsive, impulsive, non-impulsive. Right. अब ऐसा क्यों? First, let me answer the. First, let me give an explanation. So N1 is impulsive. There is no doubt about this because it is the normal reaction of collision. Okay? Any normal reaction. हाँ, बता रहा हूँ मैं आपको बता रहा हूँ. Any normal reaction of collision is impulsive. Okay? Any normal reaction of collision is impulsive, whether it is the comet and the Earth, whether it is billiard ball 1 with billiard ball 2, any collision, जिसमें normal reaction involved है, that normal reaction of collision must be impulsive in nature. So N1 is impulsive. Now, an impulsive force has a unique quality. An impulsive force will, of course, impart an impulse. Okay? An impulsive force will instantly change the velocity of the object it is acting on in its direction. This is what we use when we hit a tennis ball, when we hit a cricket ball. Cricket ball में क्या हो रहा है? What is happening? Cricket ball is coming like this. The batsman hits the cricket ball. Bat is moving in this direction. Ball is moving in this direction. So the normal reaction by the bat on the ball is like this. And this is impulsive. And because of this impulsive force, the ball acquires a velocity in this direction. So the impulsive force has this quality of imparting a sudden velocity in the direction in which it is acting. So if N1 is impulsive, that means that the small ball must suddenly acquire a velocity in this direction. Okay? So this is the first characteristic of impulsive force. Sorry. शुरू हो गया मेरा. So impulsive force when acting on an object will suddenly change the velocity of the object in the direction in which it is acting. If the object already has some velocity, then the final velocity of that object will be the velocity which is imparted or which is given to the object by the impulsive force plus the velocity that it already had. So this small sphere is stationary. I'm telling you it is stationary, and when it encounters this impulsive force N1, it must acquire a velocity in the direction of the red arrow, right? But of course it cannot because the floor is there underneath it, right? So we say that look, at the end of the day, the impulsive force is a vector quantity. Okay, and this vector quantity can be always expressed as components we say that, look, this is the horizontal impulsive force, this is the vertical impulsive force. So the horizontal impulsive force, as is the quality of all impulsive forces, will impart an instantaneous velocity to the ball in the horizontal direction. The ball will pick up a horizontal velocity instantaneously. The ball must also pick up a vertical velocity instantaneously. But then the second characteristic of impulsive forces comes into play. And the second characteristic is that an impulsive force can only be balanced by another impulsive force. Okay. The impulsive force can only be balanced by another impulsive force. So if this small ball has an impulsive force acting on it vertically downwards, then it must acquire a velocity vertically downwards. However, the floor is there, right? And N2 is the normal reaction by the floor on the small ball. So since the floor cannot allow the ball to go inside it, right, the floor will increase N2 suddenly to balance the vertical impulsive force that has been exerted on the small sphere. So the value of N2 will suddenly increase to balance this guy. So these two guys will be balanced. These are balanced impulsive force. And if this thing happens in real life, we will see that the small ball has suddenly acquired a velocity to the right. Of course, it is not moving down, it cannot move through the floor. Okay. So the vertical impulsive forces have balanced each other. Therefore, N2 is impulsive and N1 is impulsive. If N1 is impulsive, N2 must also be impulsive. Okay, now let's see what has happened to the large ball. The large ball has an impulsive force in this direction. Okay, large ball has an impulsive force in this direction. Again, वर्टिकल कंपोनेंट होएगा इसका, हॉरिजॉन्टल कंपोनेंट होएगा इसका. तो हॉरिजॉन्टल कंपोनेंट की वजह से, राइट, हॉरिजॉन्टल कंपोनेंट की वजह से ये बॉल लेफ्ट हैंड साइड में मूव कर जाएगी, या एटलीस्ट इसके राइट हैंड साइड वाली वेलोसिटी कम हो जाएगी. और सॉरी, हॉरिजॉन्टल कंपोनेंट ऑफ इंपल्सिव फोर्स की वजह से, और वर्टिकल कंपोनेंट ऑफ इंपल्सिव फोर्स की वजह से ये बॉल, this ball will acquire a velocity which will be upwards, right? This ball will acquire a velocity which will be upwards. लेकिन अगर इसका ऊपर जाने का टेंडेंसी है तो N3 उसको रोकेगा तो नहीं. N3 का वैल्यू सडनली, अगर बॉल, if the ball does bounce, if the ball does go up, then the value of N3 will become 0. So if you draw the graph of N3 with respect to time, okay, if you draw the graph of N3 with respect to time, then it may either go like this, कुछ पहले constant value था फिर 0 हो गया, okay, or it may go something like this, थोड़ा सा कम हो गया, right? But neither of these cases, in neither of these cases does the value of n jump up like this, N3 jump up like this. Therefore, N3 is a non-impulsive force. आया समझ में? Suddenly change हो रहा है N3, no problems, yes, suddenly change हो रहा है, बिल्कुल सही बात है. लेकिन sudden change का मतलब impulsive force नहीं होता.
सर इस केस में सडन चेंज हो रहा है तो फिर मोमेंटम चेंज नहीं होगा क्या?
इसका
N3 का
N3 का मोमेंटम क्या बोल रहा है? N3 का मोमेंटम, N3 तो फोर्स है ना.
सॉरी, वो बिगर बॉल का.
बिगर बॉल का जो सडनली मोमेंटम चेंज हो रहा है वो तो N1 जो उसके ऊपर इंपल्सिव फोर्स लगी है उसकी वजह से होगा. N3 की वजह से कोई मोमेंटम चेंज कुछ नहीं होगा. n3 पहले कुछ वैल्यू था, सडनली 0 हो गया, काम खत्म हुआ। क्या नहीं समझा पाप n3 वाले ने, फिर से बोल रहा हूँ भाई। मैंने आप what is part that you have understood about impulsive force? What do you think an impulsive force is? बताओ भाई, सब लोग बता दो, what is an impulsive force?
एक ऐसा फोर्स जिससे सिस्टम का मोमेंटम चेंज होता है।
नहीं, ये है impulsive force।
सर उससे सडन चेंज होता है थोड़े टाइम में।
ये होता है impulsive force, ये रहा। नहीं, sudden force नहीं। Magnitude must be large, time must be small. Very, very simple. Yes, when force exerted is very large and the time for which it acts is very, very small, that is an impulsive force. Does N3 qualify for an impulsive force on both these criteria?
सर तो डायरेक्शन नहीं मैटर करेगा, सर डायरेक्शन मैटर करता है।
क्या?
तो जो डायरेक्शन मतलब हमेशा पॉजिटिव ही होना चाहिए, फोर्स नेगेटिव।
पॉजिटिव नेगेटिव से क्या मतलब है? मैग्नीट्यूड ऑफ N3 कहाँ से कहाँ
हाँ
जा
सर,
रहा है?
मैग्नीट्यूड आपने लिया, मैं समझा, बट इसमें तो सडन डिक्रीज हो रहा है ना।
मेरे भाई क्या हो गया तेरे को? ये ग्राफ देखना, लुक एट द ग्राफ।
सर ग्राफ में इसमें सडन इंक्रीज हो रहा है।
हाँ, sudden increase of what? I cannot show you the direction on a graph paper. I can only show you the magnitude. यहाँ पे N3 का वैल्यू सडनली, N3 का मैग्नीट्यूड, इज इट ब्लोइंग अप, is it going to go to a very large number or not? That is all you have to answer. Does the magnitude of N3 suddenly grow to be a very large number or not? Yes or no? बताओ भाई।
नो सर।
बस खत्म हो गया, इंपल्सिव नहीं। मैग्नीट्यूड मस्ट बी वेरी लार्ज। तो अगर मुझे थप्पड़ मारना है तेरे को, मैं कैसे मारूंगा? मैं क्या करूं? मैं अपना हाथ लेके आऊंगा और थप्पड़ मारूंगा, या मैं अपना हाथ पहले से गाल पे रखा रहूंगा एंड देन आई विल रिमूव माय हैंड सडनली एंड ऐसे। पड़ी कि नहीं पड़ी? राइट, यू अंडरस्टैंड व्हाट आई एम सेइंग? अगर मैंने अपना हाथ पहले से रखा हुआ है आपके ऊपर एंड देन आई सडनली रिमूव माय हैंड, तो यू विल से ओह सडनली नॉर्मल रिएक्शन चेंज हो गया, मेरे चोट लग गई मेरे को। यू विल नॉट से दैट। दैट इज नॉट इम्पल्सिव।
सर
ठीक
तो
है?
अगर कांस्टेंट लार्ज मैग्नीट्यूड का फोर्स लगे जा रहा है और सडनली छोटे इंटरवल ऑफ टाइम में वो फोर्स जीरो हो गया, फिर वापस लगे जा रहा है, तो फिर वो इम्पल्सिव नहीं है।
नहीं। So let me draw this and make it clear. हाँ, हाँ, डेल्टा फोर्स क्या होता है भाई? बट या व्हाट यू आर थिंकिंग इज राइट। ओके, देखो, large force suddenly becomes zero and again becomes large,
हाँ सर यही।
not impulsive. Small force suddenly becomes large and then becomes constant, or maybe it becomes zero and इससे कोई फर्क नहीं पड़ता। This is impulsive. Okay? एक और एग्जांपल मुझे देना है। हाँ, always increases in magnitude. Yes. हाँ, magnitude suddenly increase होना चाहिए. Yes, exactly. Very good. So I apply a sudden force on a ball which is hanging by a thread. Is the tension going to be impulsive or non-impulsive in this case? Instantly after I hit the ball, is the tension going to be impulsive or non-impulsive? Very good, Abhijit. Yes. नहीं, जोएब गलत. नहीं, अबिन गलत. ना, गलत है विश्वजीत. हाँ, बात सही. नहीं, राधिका गलत है. Okay, I'll tell you. I'll tell you why. Answer my question. Answer my question. I have told you that an impulsive force will always result in a sudden change of velocity of the object in the direction of the applied impulsive force. Okay, so this horizontal impulsive force can suddenly change the velocity of the ball horizontally or not. That means that the ball is stationary, suddenly the velocity of the ball is like this. Is this possible or not? If it is possible, if it is possible, uh, then the tension must be non-impulsive. This is one way of thinking about it. The other way of thinking about it is that a vertical force can never be impulsive as a result of horizontal force. Okay? Tangential का क्या मतलब हुआ? What do you mean by tangential?
सो मतलब वो जो वेलोसिटी है वो बॉल राइट में नहीं जाएगा ना.
राइट में तो जाएगा और कहाँ जाएगा?
सर टेंशन भी तो है तो
वो तो
सर्कुलर मोशन में.
सब्सिक्वेंटली टेढ़ा होएगा ना. हम तो केवल उस
Yes,
इंस्टेंट
sir.
टाइम की बात कर रहे हैं ना जब मैंने इम्पल्सिव फोर्स लगाया उसके.
Yes, sir.
अब मेरे को बताओ ये टेंशन इम्पल्सिव होएगा या नॉन इम्पल्सिव होएगा? यहाँ पे नॉन इम्पल्सिव और यहाँ पे टेंशन इम्पल्सिव होएगा. क्यों? क्योंकि ये जो
इंक्रीज हो रहा
क्योंकि एफ इम्पल्सिव का कंपोनेंट भी है ना उसके डायरेक्शन.
हाँ, ये इम्पल्सिव फोर्स का एक कंपोनेंट हॉरिजॉन्टल होएगा, एक कंपोनेंट वर्टिकल होएगा. हॉरिजॉन्टल कंपोनेंट की वजह से हॉरिजॉन्टल वेलोसिटी आएगी, वर्टिकल कंपोनेंट की वजह से वर्टिकल वेलोसिटी आएगी. ओके, हॉरिजॉन्टल कंपोनेंट की वजह से हॉरिजॉन्टल वेलोसिटी आएगी क्या? हाँ, बिल्कुल आएगी. वर्टिकल कंपोनेंट की वजह से वर्टिकल वेलोसिटी आएगी क्या? नहीं आएगी, because the string is inextensible and therefore the ball cannot move downwards. This means that the tension will suddenly become large to counter the vertical impulsive force, and therefore the tension will be impulsive in this case. Okay. Okay. So please write this down. Of course, as you stretch that, spring. Basically, you can treat it as a spring, right? When you stretch that, you cannot stretch it suddenly. Suddenly, its length cannot go from 0.5 meters to 1 meter. The length of that object go from 0.5 to 1 meter after having been 0.6 meter, 0.7 meter, 0.8 meter, 0.9 meter, then 1 meter. Right? चलो इसको लिखो पहले. नहीं ज़ोएब, अगर आपने स्ट्रिंग काट दिया तो इम्पल्सिव टेंशन नहीं है. हाँ, एग्जैक्टली. हो गया, लिख दिया. नहीं राधिका, आज तो नहीं हो पा रहा. एक्शन वाला पॉइंट क्या नहीं समझा तेरे को? अगर दो सरफेसेस के बीच में नॉर्मल रिएक्शन इम्पल्सिव है तब वो दो सरफेसेस के बीच का फ्रिक्शन भी इम्पल्सिव होएगा. Friction cannot be impulsive on its own. Okay, let's do. ही यार जो है हर जगह है, इसका क्या मतलब, केवल यही एप्लीकेबल है. हो गया ना, लेके आना पाथ, आगे बढ़ूं मैं. चलो, लेट्स डू अ वेरी सिंपल क्वेश्चन. टफ वाले क्वेश्चन नेक्स्ट क्लास में देखेंगे. स्टिक करके तो मूवी करेंगे ना. गुड सत्यम, यस. क्या हो गया भाई? नहीं विश्वजीत, 1 into 11 is equal to 11 into v. v is equal to 1 meter per second. ये आया सबका? This you managed to find? तो अगर ये निकाल दिया तो फिर इसके बाद तो कुछ नहीं करना है ना. Let me put this in clearer terms, maybe. So since f external along the x-axis on the system 1 kg plus 10 kg is equal to 0, this implies that momentum of the system along the x-axis must be constant. So the initial momentum must be equal to final momentum. Initial momentum is momentum of the 1 kg block plus momentum of the 10 kg block. Final momentum is the momentum of the 11 kg block. So 1 kg block का momentum है 1 into 11 plus 10 kg block का momentum है 0 और 11 kg block का momentum है 11 into v. This gives me v is equal to 1 meter per second. Okay, and now I can simply say that impulse on the 10 kg block is equal to change in momentum of the 10 kg block. Final momentum minus initial momentum of the 10 kg block. Final momentum is 10 into 1 because its velocity is 1. Initial momentum is 0. So this must be 10 kg meter per second. क्या समझ में आया? Okay. Chalo, so we will continue then in the next class. And हम पूछा रजत पूछ रहा कितने लेक्चर में खत्म हो जाएगा ये. तो ये वीक में खत्म हो जाएगा. This week. In fact, this week we'll start with the next chapter also. ठीक है? HCV प्लीज करना शुरू कर दीजिए. रोटेशनल. HCV प्लीज स्टार्ट विद HCV. रोटेशनल डायनेमिक्स पर. रोटेशनल क्वेश्चन. ऑफलाइन कब होगा मुझे क्या मालूम है. नोटिफिकेशन. चलो, okay. I'll see you guys